Welcome to Chemistry with Dr. Z. I'm Dr. Z. In this video, I'm going to talk to you about the allotropes of carbon. So what are allotropes? Allotropes are different structured forms of the same element in the same physical states. So any allotrope will only consist of one type of atom which are linked together by covalent bonds. The examples of the allotropes of carbon are diamond. So diamond is one of the giant covalent structures, and diamond, it's only formed of carbon atoms. Each carbon atom is linked with four other carbon atoms with four covalent bonds. Um, this is why diamond is very hard because the covalent bonding between the different carbon atoms is are very strong. So it's very hard, and also diamond has a very high melting point. The high melting point is due to the need for high energy to break the strong covalent bonds between the carbons. A diamond doesn't conduct electricity because it doesn't have any free electrons or ions to carry the electric current, so they don't conduct electricity. The second type of the allotropes of carbon is graphite. Graphite, again, is one of the giant covalent structures. And graphite is different from diamond because in graphite, each carbon atom has only three covalent bonds, creating sheets of carbon atoms arranged in hexagons. So each carbon atom has only three covalent bonds with three different carbon atoms. And because the carbon has the electronic structure of 2,4, that means it has four electrons in its outer shell, and only three out of these four electrons will contribute in making the three covalent bonds. That means there will be an extra electron that will be free or delocalized, not taking part in formation of covalent bonds, and so graphite can conduct electricity. They can conduct electricity because of the presence of the delocalized electrons or the free electrons, so they can carry electric charge. There are strong covalent bonds between the atoms in each sheet. However, the different sheets, there are no covalent bonds. Instead, there are weak bonds between the layers or the sheets. And because there are weak bonds, that means that the different sheets are held together weakly, so they are free to move over each other. This is why graphite is soft and slippery, and it's ideal as lubricating agent. They still, however, have high melting point. So melting point of graphite is still high, and this is because of the covalent bonding between the different carbon atoms within the sheets. The third type of the allotropes of carbon is graphene. So probably you've heard of graphene a lot these days. Graphene comes from graphite. So graphene is basically only one layer or one sheet of graphite. So one sheet of carbon atoms joined together by covalent bonds. Each carbon atom will have three bonds, same way as graphite because they come actually from graphite, and the still gonna have a delocalized electron or one free electron, so graphite can conduct electricity as well. The sheet of the graphite is only one atom thick, so that makes it as a 2D compound rather than 3D because as we can see it's only one sheet. The covalent bonds between the atoms makes it very strong with very high melting point. Graphite is very strong, has very high melting points because of the covalent bonding. However, because it's only one sheet of carbon atoms or one layer of the graphene, one layer of graphite, and then it's very light. So it can be added to composite materials to improve the strength without adding much weight. So it's very strong and very light. And because it can conduct electricity, they can be used in electronics. So the properties of graphene make it perfect to be used in composite material and also in electronics. The fourth type of the allotropes of carbon is the fullerenes. So fullerenes is not actually one of the giant structure. Fullerene is considered as a kind of big molecule. It's formed only of it's formed only of carbon atoms, and each carbon atom is also linked with three different carbon atoms, making taking a shape like closed tubes or hollow balls. Um, the carbon atoms, which make three different covalent bonds with three other carbon atoms, they are arranged in polygonal shapes, so hexagons, pentagons, and heptagons. One of the firstly discovered fullerene was the Buckminster fullerene. Buckminster fullerene has this shape, the shape like a hollow ball, and it has 60 carbon atoms. So the structure of the fullerene is C60. It consists of 20 hexagons and 12 pentagons and has a molecular formula of C60. Fullerenes has very specific and unique uses due to its unique properties and shape. So first of all, it can be used in drug delivery. It can be used in drug delivery because the atoms of the drug or molecules can be trapped inside the fullerene as a cage, and then it can be used to deliver the drug inside the body into the site of action. Um, Also, it can be used in industrial catalysis. Fullerene itself is not used as a catalyst, but it's used in industrial catalysis because catalyst can be attached to the surface of fullerene, and this provides a very large surface area for catalysis. Remember that it's not used in itself as a catalyst, but it can catalyst can be attached to its surface and it can improve the catalysis by providing large surface area for the process. They also make good lubricants. Another type of the fullerenes are the fullerenes nanotubes. So we said that fullerenes can be arranged as hollow tubes, and these tubes can conduct electricity and thermal energy because we said that fullerenes actually have free electrons to move as well because of they make only three covalent bonding, leaving one electron free to move. These nanotubes are made out of carbon as well because this is fullerene, which is one of the allotropes of carbon. One of the special properties of fullerene and fullerene nanotubes is that it has high tensile strength, meaning it doesn't break when stretched. This is why nanotubes can be used in electronics to strengthen material without adding much weight. They are very, very light in the same way as the graphene, and they conduct electricity as well. So they can be used in electronic, and they also can be used to strengthen material without adding much